I'd like to introduce Mike. Mike DiCasola is expert in the color industry. He's been doing color reproduction and related for over 20 years and has a wealth of information to share. So with that, I'd like to turn it over to Mike.
Thanks, Jeremy. So thanks for attending. Just so you know, we're almost at max capacity on the webinar, which is always exciting to see. There's a lot of familiar names there and some new people too, so welcome today. Normally when we do these webinars, we like to start off by saying, why are we interested in this topic? What's the point, really? And really, the idea for this webinar came out of what I like to call the myth of pleasing color. And we're all familiar with this term, especially in large format display graphics. Very often we hear people talk about, real color accuracy, matching color at the level they do for commercial print. I don't need to do that because, I'm just selling pleasing color here today. And so if a customer walks in and they have a file that looks like the file in the background here, and we print a sign that has the color in the foreground here, we say, well, that's close enough. It's good enough color to sell what I need to sell to my customer. And what we'd like to educate our customers on is that good enough color makes you a good enough print provider. It makes you a good enough vendor. And a great example of that, it's easy to say, but we run into this practically in the field. One of our customers is one of the largest footwear manufacturers in the country, and they represent about 25 different brands that you'd know very well if I were to list the brand names off. And they have, like many large corporations, they have an in-plant graphics department. And in there they do copying and things like that, but they also have two large format inkjet printers, which they use to print things like, mock-ups for in-store signage, or if they're having a big event, they're printing signs and things like that. And what we've witnessed is, in this scenario, they only use a print driver, and they very much buy into this myth of pleasing color, good enough color. And what we've observed is that their customers, these brands that buy from them, and literally there is a transaction, they're selling their services to the brands internally, their customers have bought into this myth. They've actually trained their customers that they can only provide good enough color. So their customers, these brands, have come to learn very well that when color really matters, they have to go somewhere else. They have to find a different vendor when color really matters. And so therein is the myth. And when you think about good enough color, what you realize is that even if that's what you buy into, often good enough color still isn't good enough. It's not good enough. Often we'll see when we're working with customers, they have their own internal employees in production. And these production employees even are not, they're printing off jobs, they're looking at the results, and they're saying, I know I can't sell this to my customer. If my customer sees this color, they're not going to go ahead and they're not going to accept it when they come in. And so what ends up happening, we get into this trial and error rework process where they're basically trying to change curves, select a different profile or what have you to try and get the color to come out correct. And as we all know, that ends up in wasted time and materials. But again, thinking back to our customer where they've trained their customers to go somewhere else, it's wasted opportunity. So today, what we want to talk about are three main topics. One, we need to start understanding how to quantify color difference. So often we look at color and we say, well, is it good enough or not? How do we quantify whether or not the color is good enough or not? I want to talk about some color observations that we've encountered in the field dealing with large format display graphic providers and where color falls down. Why is the color isn't always as accurate as we'd like it to be? And then we'll end with some color matching tips and some resources for you to take away. Again, it's a 30-minute conversation today. Mostly I'll be doing the talking. If you have any questions, definitely use the Q&A chat, and we'd be happy to address those. But we're going to cover a lot of material in a short amount of time. So the first question that has to be asked when we're trying to understand does color matter is the first question is, can you trust your eyes? And we've all seen graphics like this on the internet where we have optical illusions that trick the mind and the brain to see color maybe different than we think it might be. Things like the diagram on the right where objects appear to move when we know they're not moving. If you're not familiar with the very famous now color cube in front of you, what's unique about this cube is that the brown square on the lit top in the center and the bright orange square in the center in the darkness are actually the exact same color. But our eye and our brain are looking at those colors in context and telling us that they're very, very different from one another. So we've seen these things, and we know that we can't necessarily trust the eye when it comes to judging color differences, as an example. But maybe an even bigger question is, can you trust your customer's eyes? So one of the things that you can do is that there's all sorts of tools and tricks or tools and on the internet where you can go and look at things like color blindness. That's a great website right there. Of course, it's not a clinical study on color blindness, but it's a great little tool to kind of give you a judge of color blindness. Jeremy's going to put these URLs into the chat, by the way, so that if you want, you can copy paste them and then use them on your own and go to those sites later. The Hutter-Hugh test was a test originally developed by the Munsell company, now owned by X-Rite, and this is an online version of that test. And what it does is it measures your color acuity, and that means your ability to tell the difference between very small shifts in color. So how well can you determine small color difference? I'm also going to talk a little bit about a specific customer today. It's a customer we've dealt with over the years through a number of our other customers that we've worked with, and that's Best Buy. So we're going to shelf that for a second. We're going to talk about the eyes of Best Buy and why it's important to quantify color differences. Most people who've been around color for a while will be familiar with the term delta E. And if we discuss delta E, what is that? It's a measurement of the distance between two colors that are supposed to be the same. So two color samples that are supposed to be the same, and we can use delta E, take a spectrophotometer, measure those colors, and come up with an objective measure of how different or same or similar two colors are. So it's an objective measure of this very subjective matter. So here we get a little image that kind of exemplifies this for us. We have a target color, that's what we're trying to shoot for. We measure that with a spectrophotometer, we get some colorimetric values. We measure the sample, what's actually printed off the printer, and we get this delta E number. In the bottom you see we have a total color difference that explains to us how different those colors are in terms of a visual color match. So each delta E, in theory, is one unit of visual color difference. When you start talking delta E, you will quickly find that there are many equations for delta E. The concept of delta E for color difference really came out of color science in the 1970s. The equation that was used back then was adopted by the CIE, which is the standards body that certifies equations and things and make sure we're all using the same math. And in 1976, that was certified as an equation for color difference. Now, what's interesting about CIE 76 is that delta E equation is purely graphical. It's mathematical. We plot two dots in a three-dimensional color space, a three-dimensional graphing space, and we measure the difference, and that is our delta E value. Well, quickly, the color scientists learned that our eyes and our brains visually tolerate color much differently than the math suggested, much differently than this simple graphical model. And so in the 1980s, a new equation was introduced called CMC, which was the first visual equation. So this equation attempted to adjust the math to more line up with how we as humans pass and fail color differences from one another, how close or different two colors are. That equation has continued to evolve and continue to get better and better at mimicking how we as humans pass and fail colors. The accepted delta E equation now is called CIE 2000. By the way, we have a website up there from Bruce Lindblom, brucelindblom.com. Jeremy can put that up in the chat as well. And it's a great resource if you're interested in what these equations are. There's some calculators that he has online where you can type LAB values in and see delta E values. So a really great resource to learn a little bit more about delta E. But the real question is, do these equations matter? So why do I care that there's this 1976 equation or this 2000 equation? And I like to show this contrast of equations because it helps us understand this concept of can we trust the customer's eyeballs, or can we trust just visual? Why do we need this subjective measure of color? So I have three colors that we printed out over on the left-hand side, a green, a yellow, and another yellow. And we printed them one way, and then we changed the profile, and we printed them again, and then we measured the delta E. And what's interesting about these is if you look at the green, and by the way, the eye actually is pretty forgiving on greens and yellows when it comes to distance in color measurement to visual analysis as well. So when you look at the green, you can see in delta E 76, the green was measuring up about a 4.5 delta E. But yet when we measured it with the visual tolerance, with the CIE 2000, it went to a 1.65. But look at the yellow. So I mentioned the Best Buy story before. So Best Buy, if you've ever provided graphics for Best Buy, you will know that to become a vendor for Best Buy, you have to go through a certification process. And it doesn't matter if you're printing large format graphics for them or offset or even internet images. Anything you do color for Best Buy has to be, you have to go through the certification process. So at one point, they were using the Delta E 76 model for tolerancing. And when it came to Best Buy Yellow, they had that tolerance set to a 2.0 tolerance. And so one of the things that we found is in trying to help various customers that we have with that certification process is that you could print two colors that visually would look exactly the same. The yellow would match exactly to their visual tolerance, their visual target, but yet it would fail the numerical, the measurement, because it was over 2 delta E. So here you see that both yellows are over that mark of 2 delta E. One's a 2.98, the other is a 3.64, but yet when we go to the visual tolerancing method of Delta E 2000, one of those yellows is less than 1 delta E, less than one visually different color unit, and the other one is just slightly over 1 delta E at a 1.12. So this was a great example of where, you know, we really couldn't trust the customer's eyes, but almost in the backward way that we had presented this. They were using a measurable, quantifiable pass-fail for their delta E, but because they were using the wrong equation at that time, they were actually failing things that visually were passing. So it's important to quantify your color difference and know when something's different or the same, but it's also important to make sure you're using the right equations and the right technology as well. Notice the grays on the right. Grays and oranges, the eye is typically less forgiving, much less forgiving on when it comes to color difference. So a very small change between the two plotted lines in a color space will visually be apparent to the eye. So it's kind of interesting that when we look at the Delta E 76, which was graphical, it was about a 4 delta E, but also visually when we use that equation, notice it is also a 4 delta E. So this is something else that we've learned over the years, is that because our brain tolerances colors differently, we have to, you know, be more forgiving or pay more attention to certain colors when it comes to certain customers as well. So I just threw a ton of information out there, and I threw all sorts of delta E numbers out there, right? So we had a delta E less than 1. I mentioned this visual color difference unit called the delta E. We had 4 delta E. We had 3 delta E. So here's a question. How close is close enough? We're going to throw a question up here real quick for you guys to answer. So if you could quickly answer the question up on the screen. What is an acceptable delta E in order to ensure a good visual color match? We're really going to leave this open for a very brief amount of time, and then we'll close it. And look at the results.
So we're getting a pretty good response right here. It looks like just about everyone is finished.
Excellent.
Okay. And I'm closing the poll. Aha!
So quite a mix. So we've got 38% that think it's 1 to 3 delta E. 33% said it depends on the customer and the color. So now I admit that this was kind of a trick question. So because there are more than one answer here that are correct. First of all, anyone who talks color will agree that a delta E of less than 1, it doesn't matter what equation you're talking about, is going to be a visual match. And so to say that less than 1 delta E is going to be a good match, absolutely. What we find, especially in large format graphics, is that if the delta E is between 1 and 3 using a visual tolerancing method, pretty much odds are really good that you and your customer are going to agree that that's a good match. But the last answer is also very, very true as well. It does greatly depend on the customer and the color that you're talking about. We know why there's this myth of pleasing color, right? It's because there are customers that walk through the door that they simply want the greens to be green and the blues to be blue and the reds to be red. We get that. And so for some customers, a very large color difference, it's not going to matter. And so for those customers, you know, a delta of 5 would likely pass for them. But the other thing that we know is that our customers are getting more discerning when it comes to color. More and more people are jumping into the sign and graphic game today. If anybody who considers themselves even remotely related to print is jumping into this market segment. And therefore, it's going to take a lot more effort on your part to differentiate yourself from your competition. And one of the ways to do that is by using color accuracy. to be better than a good enough vendor. So we've talked about the fact that we need to quantify color. So what are some of the things that kind of trip up this problem? How do we end up with bad color in the first place? And so to answer this question, does color really matter? If we dig into it, we have to ask some other underlying questions. And the first one that comes to mind is, do media profiles really matter? Because every one of us probably has purchased a printer at some point that came with a RIP or came with the driver, and in the driver or the RIP, there were some default profiles loaded for some media. And it's really easy to simply go into that RIP and say, well, I want to print something. So I've got a Scrim Banner media. So I'm going to load that Scrim Banner media up on my printer, and let's see. Oh yeah, this profile, this media set, it looks like it's Scrim Banner. Let me print that and see what it looks like. And you look at it and you say, wow, that's pretty good. I'll just stick with that. Why should I go through the hassle of building a custom profile or going and seeing if I even have to download a profile from the manufacturer? So the question is, do profiles really matter, especially for media? So we did a test. We took an HBZ 6100. We loaded a very high-end photo media, and then we went into a production RIP, and we went and we selected every profile we could find that was by name or description very close to this high-end photo media that we had, and we printed a series of patches. By the way, all the patches that we're showing you today are all part of a test file that you'll get access to at the end of the webinar here if you want to do some of these same tests. And as you can probably see from the image, hopefully, there was a very large visual shift across all of those settings. And again, all we changed were the media setting or the profile. But again, we talked about we need to quantify color, right? Not just trust visual. So what happens when we quantify this color difference? So one of the swatches in here was printed using the right profile for the right media and the right printer that we were actually doing our test on. And so in that case, the gray printed a 0.90 to what we expected that color to be in the original file. But look we went all the way up to a 6.4 delta E when we changed the media profile. On orange, same thing, 1.17 using the right profile for the media, upwards to a 9.0. That's visual delta E. That's hugely different. Go back to the question that we talked about before about how good is good enough when it comes to delta E. I don't know anybody that would take a 9 delta E and call that a visual match. Okay, so the profiles that you use have a huge impact on the ability to get accurate color. You go back to that survey that we took right at the beginning. We asked some questions about a RIP versus a driver too. Again, many people that are in professional graphic printing and in large format in display graphic printing, if they're going to expect to get good color, they'll often use a RIP. Go back to that customer I mentioned in the beginning, the footwear manufacturer that has an implant. They're using a print driver, and if they wanted to get really good color, they probably can't. Well, why is that? So we have to ask the question: do I really need a RIP if I want to get good color? How big, how close can I get? What kind of delta E's are we really talking about? So we did another test. We took the same green and yellow that we were looking at previously. The green in that test file happens to be a spot color. It's a 348 green Pantone color. It's a pretty typical green that's chosen out of the Pantone book. It is a pretty close to edge of gamut color. It's a saturated color, so it can be difficult for a printer to hit depending on your printer technology. But we went through and we printed this on the printer with the right media and a profile that matched that media, and we achieved a 2.2 delta E visual to that 348 green Pantone green. We then went and just changed the profile in the RIP to something very similar, and we ended up with a 3.5 delta E. So remember we said most color matching between a 1 and a 3 is acceptable? So here we went over that threshold. We went from a 2.2, we went an additional delta E over that 3.0 threshold. We then said, okay, let's take the same file and load it into the print driver and print through the print driver and see what we get. And in this case, we got a 3.8. It did get worse, but it's still not that bad, even though we can see the progression. Now, the one kind of caveat on this is that we stacked the deck in the favor of the driver in this case. We said we want to try and give the driver the best chance. So we used a high-end Epson photo printer with a high-end photo media and using profiles that were pretty close to that type of media, because Epson has a lot of those photo type profiles available for the printer. And still we saw this delta E. But we said, display graphic printing, down and dirty, trying to print on a banner, I'm usually not doing a high-end photo media on an Epson printer. Maybe you are, but that's usually not what I think of when I think of display graphics printing, right? So then we went and we moved it over to an HP DesignJet printer. We put a banner material on there. We tried to print the same exact print again, and this time we printed on the right media with the profile, and then we went through the driver. And the driver to the profiled media, the difference was 8.5 delta E. What was interesting, many of you know that HB has a web interface that you can submit jobs through too, so we said, well, let's try that. We went through the web interface, the delta E actually went down, which was a little surprising. But you can see from the image, it was very, very, very different. So printing through a driver presents all sorts of challenges when we're attempting to get very accurate color. So one of them is generic profiles. You can see here, this is a screenshot from an Epson print driver. And if we were trying to print to this photo paper, we're limited in the number of profiles that we can choose. And often we do not have the ability to load a custom profile even if we have it. The drivers will often only allow us to print RGB data. Unless you have a PostScript engine built into your printer, one of the ways you can check this is go into Photoshop, try and print your printer through the driver, and load a CMYK file, load our test file, which is a CMYK-based file, and try and print it. And what you'll find is that Photoshop will force you to only use RGB profiles. That's a dead indication. That's a great indication that your driver's changing your files to RGB before it prints it. And when you go through that many iterations of color, it's very hard to get accurate color. And then one of the big ones is spot color support. We had over 60% of you say that you try and print spot colors to a swatch book. If you're printing through a driver, there's no possible way you're going to match a spot color, because what's going to happen is the driver is going to take the spot color, which is typically an LAB definition in a current version of software today. It's going to convert that to RGB, and by the time that color gets to the printer has no idea that you're trying to match something to a swatch book. You may be asking about images. I've been showing blocks of big color. It's important to remember that images are made of pixels. If we zoom way in, what are we going to see? Blocks of color. And so while images can sometimes hide color differences depending on the content of the image, often the really important colors are the ones that are gonna kind of go sideways on us. And so we use some of the same profiles here for these images that we've used for some of the color blocks that we've shown you so far. And you can see here that definitely you can see this shift in tone between kind of a yellowish skin tone or the brown hair to a redder hair or to a redder skin tone. So images are equally affected by these challenges. So all this begs the question, what now? What can we actually do to fix some of these problems, or what can you walk away from this seminar onto your own shop floor and look at to try and see how bad the problem might be and what you can do to make it better, right? Because it's all about improving where you're at now. One of the things we recommend is to analyze your own system. Print our test file. You should be able to see in the panel on the lower left under shared files, we have a file there called Color Patches Test PDF. There's a blue button. If you click that, you can download that PDF. So go ahead and print that through the workflow that you do today. There are some spot colors in there. So if you have a physical swatch book, compare the spot colors to your swatch book and look at it. How well did you do? Maybe if you're using generic profiles, try a different profile and see if you can visually get it better. A couple things to keep in mind. If you do have a swatch book, every one of those have a date on it. Check the date. You don't want to use a swatch book that's more than a year or two old because they are printed materials and they will fade over time. Another question, really a challenge perhaps to you if you're not already in possession of a spectrophotometer, why not? Why not go out and purchase a spectrophotometer, invest in a spectrophotometer that can give you a very simple comparison between two colors and give you delta E. We were talking before about being a good enough vendor. Imagine completely flipping that scenario around. All of a sudden you're talking with your customer and there's a spectrophotometer on the countertop when you're speaking with your customer across the way. And so it's not only are you not a good enough color vendor, but now you're better than everybody else because you're entering into a color conversation with your customer. Another big thing that you can do is use profiles that match your printer and your media. And we realize that many people don't have the tools, they may not have the software, the instruments, they may not have the time. We're offering a very awesome program right now called eColor Expert. If you purchase some of our validation display graphic media to use in your shop, we'll put you in touch one-on-one with an eColor expert, and that expert will do everything in their power to get you custom profiles, even up to shipping you an instrument if we have to do that. So it's a great resource, and again, what we're really trying to do is help people take control of color and be better than just good enough color vendors. Ask yourself if you're just using a driver, why not use a RIP? If you want some recommendations on RIPs to use, if you're not using a driver today, feel free to contact us after the seminar. once the seminar is over, you're going to go to our website automatically. You can contact us via the website. We'd be happy to enter into a conversation with you about using a RIP. If you are using a RIP and your spot color matching isn't that great, one of the kind of secrets of the trade that we've developed over the years is going in and iterating the LAB colors that are in your spot color library. And we've actually developed a software utility tool called the ChromaCalc tool, Chroma Calculator, that allows you to easily iterate your LAB values to dial in your printed spot colors to the actual physical spot color book that you have in your shop. Because in the end, that's the book you're going to use to show your customer. So spot color books or swatch books are very different from one to another. We want to help you dial your prints into your specific swatch book. And we're going to be offering that tool to you here in a moment. So some resources, some takeaways for the webinar. Remember our eColor Expert program. After the webinar, you'll be directed to our website. If you're interested in taking advantage of that, contact us through the website. You can enter something into the chat if you're interested. We won't share that out to everybody if you put that into the chat, but we'll contact you afterward and tell you how you can take advantage of the eColor Expert program. We do have the file that you can download from the shared files portion of the screen over on the lower left-hand side. Just click the blue button to download that test file. And also, for attending our webinar today and sticking through it all the way to the end, we are offering our free tool, the ChromaCalc tool. It's a LAB spot color iteration tool. You do need a spectrophotometer and a RIP. You need to be able to measure your swatch book, type that LAB value into your spot color library in your RIP. You print the spot color out, you measure the spot color that comes out of your printer, and then this tool will help you adjust the LAB values in the table to dial in your print of the spot color to the actual swatch book that you have in front of you. So if you have a customer that's got a special logo color and it's just imperative that you match it, this is a great tool. So to get this tool, what you need to do is in the chat, and again, we won't share this out, this will be a private chat, but if anyone's interested in the tool, simply chat to us either Mac or PC so we know which version to send you, and you will get an email later today with a link to the download for that software. So that was the last question, by the way. I kind of skipped ahead. The last question of the day was, do you want Mac or do you want PC? So we're just a little bit over time. It's just after 1:30 Eastern time here. Again, thank you everyone for attending. I'm going to ask Jeremy if we have any questions that came across on the Q&A there.
Yes, Mike, we do have a couple. One great question is, which swatch books do you recommend for banner and display graphics, production printing, that type of thing?
As far as referring to like uncoated, coated, that type of thing?
Yeah.
Yeah, I mean, that's a great question, first of all, and it's going to depend on a couple things. So basically what you will find most people using today are the Pantone Solid libraries. So you really have to get into the mind of your customer a little bit here, right? Because when a customer walks into your shop and says, I want Pantone 348, like we saw in the presentation, you have to know what they're talking about. So if they've picked 348U, which is the uncoated designation from the uncoated book, and you print the uncoated C for the solid, for the coated solid, those aren't going to match, right? So it's really a matter of getting into the head of your customer and finding out what they're specifying. Now, it also creates a great opportunity to enter into a color conversation with your customer and help them understand what they should be specifying. Realize if you're printing to a matte banner material, if you're printing to a scrim, to a matte poly, like a pop-up display type of thing, and you're printing on a matte surface, you are not going to be able to match many of the solid coated library swatches. So there's a great opportunity to look at the uncoated library. But typically what we end up finding is that almost any customer that's speccing a spot color, they're doing it out of Illustrator, they're doing it out of some application, and they're expecting a solid coated library. So again, it's not a great answer, but you really have to get into the head of your customer.
And another one, a question here about measuring metallics. Is there any suggestions there?
Actually measuring a metallic spot color or measuring metallic media? Do you know?
Don't know. It looks, I would guess spot.
Yeah. So metallics are always challenging, mostly because the instruments, when we talk about spectrophotometers, often you'll hear people that are in the industry talk about measurement geometry. So there are spectrophotometers that are built using different actual geometry as far as the angle that the light source is coming in, the angle that the optical sensor is gathering the light in, or even just not even just the angle, but the methodology that's used by that instrument to collect and measure color. And so in printing, we often find 0.45 degree geometry is what's across the board. So if you look at the pictures of the spectrophotometer that were in this webinar, if you grab something like a color spider or the spider device from Datacolor or something like that, they're always going to be 0.45. And that geometry is always going to pose a problem for metallic, because metallic is going to scatter the light in a way that paper or a banner media will not. So often, it depends on the application, but often if you're dealing with metallic surfaces, the only really good way to get a color measurement is to start using different measurement geometry than we're used to in the printing industry. And typically what we talk about there is a spherical unit. So they're much more expensive units. They're used in other color industries, industrial color applications often. But if whoever asked that question, if you'd like to send me an email directly and kind of talk specifically about the application, I can probably answer the question a lot better. Any others?
That looks like about it in the chat.
All right. Well, thank you everyone for attending. Hopefully you were able to get something out of this. I saw some pretty heavy-hitting color experts on the list of attendees today, so I hope we didn't disappoint in our delivery. But thank you once again, and stay tuned. We're trying to do these webinars at least once a month on various color topics relating to inkjet, production, media, and those types of things. So with that, we'll close the seminar, and thank you everyone for attending.